Good morning, everyone. Okay. So if you can hear my voice, can you unmute your mic? Just respond. Let me know that I have people who can hear me.
Good morning. We can hear
Yeah,
you.
If you
good
can hear
morning.
my
I can
voice,
hear you.
respond. Okay, thank you very much. Thank you very much. That's good. Thank you very much. And can we all see my face? I'm actually using two devices, so just a minute, please. Okay, so I want to welcome everyone to today's training session. So from wherever you are joining us, within Nigeria, outside Nigeria, Lagos, Abuja, Kaduna, Maiduguri, Kano, Akwa Ibom, Asaba. From wherever you are joining us, I want to say a very big welcome to you all, and I'm especially welcoming you to today's training session on industrial electrical safety. I'm so glad to be here this morning with us, and trust me, it's going to be a very wonderful and enlightening session with us all. So, my name is Kehinde Samson Ogumiwa, and I'm going to be your training moderator and host for this particular training. Just a minute, please. Okay, so once again, I say a very big welcome to you all from wherever you are joining us. We have a couple of people, persons that have been seen in the live class, in this class that has been a part of our training at one point or the other before. So please, if you have been a part of our training, if you have joined or participated in any of our training, just signify by raising up your hand. Just signify for me. Signify by raising up your hand. Let me see those who have attended our classes before. Okay, thank you very much, Edward and thank you very much. Thank you very much, for Prince. Okay, I really appreciate that a whole lot. Thank you so much. So I remain my humble self. My name is Kehinde Samson Ogumiwa, and this training on industrial electrical safety is brought to you courtesy CUC Concepts Training Company Limited. CUC Concept is a professional training firm. We are into professional trainings, productivity trainings, let me use the word, that cut across board, across industries that exist. Of course, yes, part of our target is to be able to bring professional trainings that, irrespective of which industry you work or which industry you belong, you will be able to benefit and while participating in this training. So our training cuts across the engineering industry, the financial industry, management, and the likes. So we equally soft skills and hard skills training that cuts across, every profession. So you joining us in this professional training on industrial electrical safety, you have not missed, you are not in the wrong, and trust me, you are in the right place. And we are going to do our very best to ensure that you get the best of knowledge, the best of our output in this course, in this training. So once again, I say welcome to you all. So what you are going to do for me before we go into today's class, we want you to please go to the e-message session, introduce yourself, tell us your name, tell us where you are joining us from, and I would love to know what your expectation of this class, of this training is. So please, let's go to the e-message session and do that for me. Tell us your name, tell us where you are joining us from, and what your expectation of this training is. So please, let's quickly do that in the next 1 or 2 minutes. Please, let's do that. I would love to see, let's introduce yourself. I've introduced myself. I would love to know you all as well. Tell us your name and where you are joining us from. Thank you very much, Robert Ihuoma. Thank you very much. So please, let's keep introducing ourselves. Let's do that. And in today's class, we have a very, very wonderful resource person who is going to be taking us in this particular training. Is none other than Mr. James Faniyi. He is a very, very renowned trainer when it comes to training. When it comes to delivery, he's one of the best in that field. He has a very, very good and firm foundation when it comes to engineering practices. When it comes to management practices, he's one of the best. And trust me, in a few minutes from now, you are going to be meeting him and you are going to be enjoying from his wealth of experience. So I want to implore us that we should give him our undivided attention. Thank you very much, Chukwuemeka Ndubisi Ibiachu. Thank you for joining us from Lagos. Thank you very much. Thank you very much, Ali Umbara. Kokoyemi Lati from Lagos. Thank you very much. Chukwuemeka Joseph from Osun State. Thank you very much for joining us. So like I did say, we have a very, very wonderful resource person who is going to be taking us in this class. So please, I want to implore you, please let us give him our undivided attention so that we'll be able to benefit from his wealth of experience. This training is brought to you by CC Concept, and this training is absolutely free. Absolutely free, I mean participating in this training. And of course, many people have been asking on WhatsApp group that we created for this particular training, that is there going to be a certificate for this training? Of course, there's going to be a certificate. It's going to be at a discount rate, and for everyone who is interested. Our purpose and goal is for you to participate in this training. Once you have seen you've benefited from it, then you'll be able to decide on your own accord to go for the certification. And yes, certification is well recognized within the country, and trust me, we have people who have been using our certification to get job opportunities, contracts, and it has been working well for them, even within and outside Nigeria. So I want you to please let us focus on the training first. So every other question, every other information that you need to get as regarding the certification, it will be passed on to you at the end of this training, which is tomorrow. So this training is going to hold for 2 days. That is today, which is Tuesday, and Wednesday, 19th of March 2025. So we have today and tomorrow, and I want you to please let us utilize and maximize the few hours that we have to engage you in this course. So once again, I say thank you. In this training, we are going to be using some of our materials to facilitate this course. Yes, the trainer is on ground here. So at the end of the class, you are going to be given the opportunity to ask questions. I want you to please, if you have your question, pen it down. At the end of the class, we give you the opportunity, you ask your question. If you have an experience that you have in the field on the job, in the field of engineering, and as it concerns, excuse me, as it concerns electrical safety, we'd love you to share it as well, so that everyone in this class can also benefit from your wealth of experience, and we can share knowledge together. So without further ado, okay, I've seen many people who have introduced themselves. Bright Asari from Ghana. Bright Asari, thank you for joining us. We have Latif, Opeyemi Latif from Lagos. Thank you very much for joining us. Undukwe Prince, thank you very much for joining us. Udwak ACN from Umaya, thank you for joining us. Olatunde from Kwara State. Thank you all very much for joining us. I think just a few people told me their expectation from this course. Okay, thank you, Bright. Bright says, my expectation is to be well equipped with electrical industrial safety in order to help others and myself to work in a well-equipped and safe environment. Oh, that's very good, Mr. Bright Asari. Thank you very much for that. And also Dan. So there are a whole lot. I can't take everything, but because of our time, I want us to keep it short, and so that we can proceed in today's training. Daniel Akosam, thank you very much. Daniel Akosam from Ghana, thank you for joining us. Choice OKK, thank you for joining us as well. So without further ado, please, if you can see my screen, I would love you to give me a thumbs up. If you can see my screen, just give me a thumbs up. Let me bring this down first. Okay, thank you very much. Thank you very much. And let me bring this down first so I can share the main screen. Okay, so we are streaming live on YouTube as well. So please, if you have anyone who is not who didn't have the opportunity to join in this live Google Meet class, you can as well share with them the YouTube link. We already dropped the YouTube link on our WhatsApp page. So please go to our WhatsApp. You can pick up the YouTube link from there and share with them. Some people, perhaps they don't have a good reception around their place or where they are. So they can easily access the training via the YouTube link. So at times you can just work with both links, both the Google Meet and the YouTube. Okay, so please, and I also, once you are joining our YouTube, I will also encourage you to please subscribe to our YouTube channel. We have loads and lots of training videos, live videos that we have dropped, that we have had over the time, and we always drop them on our YouTube platform. So once you go on our YouTube page, please subscribe so you can have ample access to those trainings. Yes, very soon we'll be taking them down, but for the meantime, we still have them, and you can still have ample access to them. So go there, trainings on project management, trainings on other engineering professions, maintenance, industrial machinery maintenance trainings and the likes. So you don't want to miss that opportunity. So please go there and subscribe to our YouTube channel so you'll be able to have ample access to those trainings. Okay, so without further ado, I want us to go straight into today's class. So please, if you can see my screen, I want you to give me a thumbs up. Give me a thumbs up. Let me know you can see my screen now. Thank you very much. Okay, so Bernard, Christopher, thank you so much. Okay, so we'll be going straight into today's class. Please let us maintain decorum. Yes, like I did mention, at the end of the class, if you have your questions, you have the opportunity to ask your question or to share from your wealth of experience. Mr. Uwem Uwa, Engineer Uwem Uwa, thank you for joining us. He has been one of our very ardent and good follower when it comes to every of our training. So thank you for joining us, Engineer Uwem. Okay, so we are starting today's class. So please enjoy your class.
The training is industrial electrical safety, and I'll be facilitating the training with you. I've been introduced already, so I don't need to do that again. My name is James Fani. I don't like telling people my profile, but if you are so much interested, you can find out. So I've seen that we have a lot of people who are actually electrically inclined among us. So that's fantastic. That will make the training easier for me. And if you are not also an electrically grounded person, or you don't have the background in electrical, because a lot of people that saw electrical safety, they will think that, oh, it's only people that did electrical, and that would be a wrong mindset. When it comes to industrial safety, it is all encompassing. Industrial safety, affects you either you are working in a particular department or you are working in another department. In as much you gain access to the factory or you gain access to the industry, you enter from the gates. All hazards that are present are also what? Yours. So you can prevent them, you can guide yourself against them, and you can as well mistakenly or innocently or ignorantly expose yourself to those hazards. And that is why you need to have the knowledge of the dangers around. You need to have the sound understanding of things that could go wrong at work. Either you are actually interacting directly with some equipment or not. You need to really be aware. And it's not really, especially in this part of the world, I mean Nigeria or Africa, sometimes I don't blame employees because when there's what we call induction, when you get a new job, irrespective of your experience, when you are moving from a company to another company, transiting from one company to another company, if you like, write 20 years work experience in your CV, you need to be retrained. You need to still go through induction. Because the environment where you are coming from is not the same with the environment where you are right now. So there might be some things that were not dangerous or that not really pose high risk where you are coming from, but here in our own company, maybe we have a history with it. Maybe a lot of people using a particular machine, they have had injuries or cases of accidents with it. So we need to actually alert you also. We need to really give you another orientation, because there shouldn't be a situation where a worker or an employee will be involved in an accident and then you begin to blame the company, saying that, oh, I was not told, I wasn't aware. For instance, let me come down to many of us, especially the electrically oriented people, those who are engineers. Because you have little knowledge of engineering or electrical, sometimes you tend to even do things that are against electrical safety. Just that there are few people back then that their own fan inside their room, they are the only one that can operate it. You dare not touch the switch in their room because they are the only one that can operate it. A lot of us expose live conductors in the room of a so-called electrical engineer just because he believes that he can always find his way. He can be careful. Forgetting, days that he might be stressed or he might be forgetful about, what he was doing. There was something I saw which was very, very wrong with, electrical safety. And where I saw it, I was actually a lot disappointed. I could remember, my very first time of going to a power holding office, NEPA office, so to say. So, and reaching there, what I saw, I could not even say that I was in an office where they have what electrical work ethics. If you look at the conductors, the way conductors were left flying here and there on the distribution box that they themselves they are using to supply their own building. It was left open, a lot of loose cables, a lot of twisting, joining, finding that you dare not call another person who was not there or who is not actually familiar with that. You dare not call that person to come and troubleshoot that particular circuit or trace any fault. It's going to be in soup. I've had the situation before also where people do, connections. We have practice in engineering, electrical engineering, so to say. You say, okay, let's use red cable for live. Let's use black cable for neutral. It is not that if you switch the cable, it will not really work. There won't be supply. No, but it's because there's an ethics. There is regulation. There is, and all these things, they are for to uphold electrical safety, such that if I am coming to troubleshoot, a particular connection, I should be rest assured that when I see red cable, I know that it's carrying light. When I see black, I know that it's carrying light. But, OYO is your case if you work like that, especially in this part of the world. Because you still have to carry your meter. I've seen where, the red cable was coming, carrying live circuit, and then maybe the wire was not enough. They just join it with another black. And then by the time you see the output, you will see black. You'll not be wondering which one is live, which one is this, and all that. That's why you must always have your meter. So, enough said about that. I don't really want to be too deep into, the electrical in and all that, because we may have people that are not electrically oriented among us. So let's get started on the training. Okay. Now, the first thing that we must know is that when it comes to industry, there are people who we call, qualified electrical workers, and there are people who we refer to as unqualified electrical workers. Who are the qualified electrical workers? I've seen so many here, perhaps, okay, that they said, oh, they are electrical engineer, or maybe they have the background in electrical engineering and all that. Now, people who have the knowledge, who have the work standards and the regulations guiding an electrical work in a particular industry, we can refer to them as qualified electrical workers. These are not just people that have ideas. These are people who have gone through trainings or who are actually professionals, understanding what electrical connection is or what an energized equipment is. Now, another thing, based on the electrical standard that we must understand, a qualified electrical worker may not be a generally qualified electrical worker. What do I mean by that? Somebody may be qualified on a particular equipment and yet is not qualified on another equipment, though both of them are not electrical equipment or they're actually using electricity. So you cannot say generally this person is just qualified. Take for instance, you are saying that somebody who can actually work on your socket inside your room because it's an electric, is a certified somebody that can work on electricity. So because that person can work on your socket, you then call him to come and work, to come and climb the poles on the streets. That would be definitely wrong. So somebody might be trained such that he can what? Climb what? He can walk at heights, connect what? Cables from one pole to another, from one joint to another joint. And another person might be trained that domestically he can actually troubleshoot and work with electrical gadgets in the house. So there is nothing like generally qualified. There is only a relatively qualified electrical worker. Now, who are the unqualified electrical workers? These are the unskilled people. And in most cases, a trainee, an industrial trainee can also be referred to either unqualified or qualified. He is only considered qualified if he is working under a supervisor who is actually monitoring what he's doing. I could recall my Dangote Academy training. I went through Dangote Academy training, and I was so lucky to be among the first sets that entered into that training. And because of my passion for power, I actually chose electrical because we had a lot of options. Now, for the first few months in the training, we will go through the theoretical aspect in the classroom, and then they take us to Dangote Obajana cement plant in Kogi State. Now, anytime we are working, all of us, we actually attached to Indians. We were working with Indians, and they were actually saddled with responsibility to train us. Now, the training is that sometimes they may not even allow you to actually do any connection. For a while, you have to keep watching. You keep watching what they are doing. At a point, they can give you flyer. They say, okay, twist this together, take this course to never do this. At that point, you can't call us qualified electrical workers because we are still under the supervision of someone. You can't work on your own. Anything can go wrong. And that's why electrical safety is very important. Electrical safety can lead to death just within a microsecond. Electrical safety is so important to the extent that if you know how many lives, that electrical accidents, on job are taken, if you know how many lives that these, there was a statistics of this, being done, that across industries, every day, a life of an employee, across industries, every day, a life of an employee, at least a life of an employee is being lost due to electrical, accidents on the job. So you can imagine that is every day, even as we are talking right now, today, if you do your statistics all around industries, across industries, you must find out that electrical, faults or electrical accidents or electrical hazard has taken or claimed a life of an employee. When you make mistake when it comes to electrical faults, you can actually lose your life and at the same time take many lives with you, along with you. Mechanical faults or other, interactive or physical faults or safety, yes, they are also dangerous, but we have seen some cases where people put their hands inside a rotating machine, they just lose their arm. Maybe they use the right arm, the person may still stay alive. But if it comes to electrical, you may not even live to tell the story. You won't be amputated in most cases. It's not like you are going to be you are going to lose one hand or lose one eye. In some cases, you lose life. And that's actually what the extent, of the dangers that we have in electrical fault. So when we talk about qualified and unqualified electrical workers, you must know where you belong. That does not mean that you are not at risk, whether you are qualified or unqualified. But what we are saying is that if you are not qualified, the only thing that you bother your mind with now is how do you protect yourself against electrical fault or electrical hazard. But if you are such a person that is qualified that you interact with it, yes, yours also is also a question of how do I protect myself when I'm working on an energized equipment. So these two things are very, very important. You need to know where you actually belong. We don't encourage people who are not trained to work on electrical equipment to just say, oh, I'm experienced, I can do it. That is against safety rule. But even you as a mechanical man, on the equipment where you are working, of course, it's going to be electrically energized. So you need to be aware of the dangers, and you need to learn what to do when the dangers also arise. That's what we are talking about. So let's move very fast. You need to familiarize yourself with the general requirements of the standard. Okay? You need to identify common electrical hazards. You need to understand the definition of electrically safe work conditions, recognize electrical equipment defects and hazards, understand basic wiring design and protection, and identify wiring methods, components, and equipment for general use. Don't worry, the material is actually be provided. So if you are not actually following with what we are actually displaying, there are so many things because we are not here just for theories. I'm actually here for us to actually have the practical views of what we are discussing. Now let's look at causes of electrical accidents. What are the causes of electrical accidents across industries? Now the first one I will be discussing is unsafe equipment and installation. There are so many equipments that, due to poor maintenance, they may actually become unsafe for you to use. When we are using the word unsafe, we are talking about perhaps they are not adequately maintained. Back then in some industry, I will not be mentioning names of companies. There are some times that employees who supposed to maintain a particular machine might actually forget. Okay, they might forget. There are some machines that every 10 days, every 15 days, okay, that you need to actually maintain them. So sometimes they may actually forget. And when you do this, just know that you are putting the life of the person working on that equipment, you are putting the lives of those, you are putting it at risk. Because interacting with that machine will now become dangerous. It will become unsafe because there is an unsafe, maintenance culture already that you as a person who was actually in charge of maintaining that machine has already promoted. So you need to know that from unsafe equipment and installation, you can actually have electrical accident. These can actually result to electrical accidents. We also have what we call unsafe work environment. Unsafe work environment means that if we are working, on a day that it does not rain, that environment may be safe. But on the day that it rains in that environment, it may be unsafe for us to work in that particular environment. If you are working, and the land or the ground or the floor where you are working is wet, that has become unsafe work environment for you. Meaning that there are dangers all around. And if you are also working with an unsafe work practices, what are the unsafe work practices? There are procedures across industries, and every industry have their own procedures peculiar to them. That if you are going to work on a particular equipment, These are the process and procedure that you need to follow. So when these three things, these are the three causes of electrical accident. Number one, I mentioned unsafe equipment and installation. Number two, I mentioned unsafe work environment. And number three, I mentioned unsafe work practices. All these, result to electrical accidents. Now look at the list of unsafe equipment and installation. What if you have faulty insulation? If the insulation, of the particular device or equipment that you are using, if the insulation has been broken. Now, what do we call insulation? For the sake of those people that are not electrically branded, insulation is those things that you see as rubber. You can call it rubber, that actually protects, you from directly touching the conductor. So it is the insulation material that we refer to as insulator. So that's, we are talking about faulty insulation. If you have experienced this before, there are sometimes that if you forget that the plier that you are using has already had a cut or a breach in its insulation, you may actually receive a tingling feeling, like a tingling sensation when you're working on electricity. To just bite you a little, and then you will see that it's because you are using a 40-watt equipment. Now, I also had another experience back then when we were supervising the Ibese cement plant. That's Dangote Ibese cement plant. I was so lucky that when they were building the Ibese cement plant in Ogun State, part of us as Dangote academic candidates were actually used to also supervise the installation of the electric motors and other electrical gadgets. Now, if an electric motor is of a particular kilowatt, and you want to actually connect the earthing of that electric motor, there are some of them that you can connect the earthing cable to the body of the motor, and there are some of them that you can actually take the earthing cable to the ground based on the rating of the electric motor. At least anything from 50 kilowatt upward, you should be able to connect the earthing cable directly to the ground so that it can be safe. So these are practical explanation that you can have for the faulty insulation. What about improper grounding? I've mentioned that. Loose connections. Now this can also cause issues. When there is loose connections, and that's one of the things that the electrical people do during maintenance. They have to retighten all the connections. They have to be sure that all the connections are firm and tight. Because if this is not properly done, there might be spark. And in some cases, we call it arcing. There might be spark. Let me show you some of those the pictures to all those things. So you can see loose connections. Let me get you a picture of spark that you can actually feel when the connections are not tightened enough. I think I should have one of those pictures here. Now, if you can hear me clearly and you are in tune with me in this training, either you're on YouTube or you are with us on Gmail, just go to the comment section and put "I'm with you." I want to be sure that I'm actually training people here. So you can see this. So this is the loose connection. Can you see this image right now? This is the loose connection. So you can see this is the loose connection. It is not properly tightened. And then the wire, they actually touch. There may be live cable touching the neutral cable. A lot of things. It may actually touch even the body of the equipment, and then that might actually result to a fire incident if not properly controlled. So if you are with me, I want to see you typing "I'm with you." I'm with you. I am with you. I am with you. Thank you so much. Thank you so much. That's Chidima. It's Chidima, an electrical engineer. That's fantastic. Now let's continue. defective parts, okay? Are there some part of the equipment that needs to be what replaced, or that maybe have been repaired before and they are supposed to be replaced? Most of these things happen in industry. Sometimes, because of the corruptions, there are some part of the equipment that they will tell you, oh, replace this what equipment. But because the person in charge wants to manage money, he will carry what the old one, repair it, and then will install it back, instead of him to what buy a new one and replace. It does happen a lot. And you that you are working on equipment, you don't know that what there is a particular part of that equipment that is already defective, that's not working properly. This can actually what become an unsafe equipment, okay, and then it can result to an electrical what accident. I've mentioned ground faults, unguarded live parts. What about unguarded live parts? Okay, let's see some images of that. Unguarded live parts of the cable. You know, when we say guard, there are some equipment that the guard is just to separate you, you know, from the part of the equipment that can give you a shock or that can result to an electrical accident with you. Okay, these are what guard. Look at this cover. Okay, this cover, you can see that this man, before he's actually what touching the switch, he raised what a particular guard. He raised it up. This is a guard in case if there are what electrical faults or whatever that may actually occur here. This guard is actually what protecting. You know, is interfacing between you and the machine. Okay, there are so many other, you know, fantastic images that you can see with what guard, okay, being used. Okay, so when we move on, if I see any of those images, I will actually what bring that up also. So we have unguarded or light part. If the part is not what guarded, definitely the equipment become what unsafe. Undirected equipment. What about undirected equipment? When you have some equipment which happens a lot of people who believe that they have experience, you just look down on some equipment, you undirect them. This one cannot kill me. What can happen to this one? This one cannot kill me. But it does happen. As much as small as your phone is and the voltage in your phone, there are a lot of people who have not used phone, you know, safely before and plugging their phone while it is actually what in use, okay, and then there are, you know, many lives have been lost due to that, and there is a lot of people that have what terrible story to actually what tell about that. Okay, so let's look at this. What are the unsafe, okay, work environments? Unsafe work environments. What makes the work environment unsafe? When you have flammable vapors, liquids or gases, the environment becomes unsafe because any little spark, you know, can result to what? Explosion, can result to what? Fire incident. When you have a corrosive atmosphere, okay, that's an unsafe work environment. When you have wet, I've mentioned this before, wet and damp locations, this is also what? Unsafe work environment. All these can actually lead to what? Electrical what? Fault, or they can lead to what? Electrical what? Accident. What about unsafe work practices? For example, you are working on an energized equipment. When we say energized, we are talking about what? Equipment that is still plugged. This is so common. And mind you, you have to, you know, ensure that your safety is prioritized. Because I've seen a lot of people, and I've heard about a lot of people, you know, who actually wanted to impress their boss, but they lose their life in the course of, you know, demonstrating loyalty in a stupid form, in a stupid way. How is your loyalty? How can it become stupid? It becomes stupid when you are putting your life, you know, at risk just because you want to work on an equipment. What is the normal practice? The normal practice of electrical safety is that, no, you should do all you can to ensure that the equipment is what? De-energized. De-energized means that what? You remove what? The power supply from it. When you are working on any equipment, it should be a dead equipment. Except some what? Some tiny cases. There are some tiny cases, exceptions that we normally have where you may not have to what de-energize what the equipment, but there are other procedures that you must, undergo, which in the course of this training is going to be mentioned for you to actually what guarantee what the safety of the person working on the equipment. But the first thing, the foundation is that what every electrically what energized equipment must be what unplugged or de-energized when you want to work on it. So failure to de-energize electrical equipment when what inspected or when you are working on it, that is an unsafe work practices. I've had a lot of people who testify to this. I have a friend back then in the academy, so he was working with his boss, and his Indian boss. And normally, if you have interacted in the electrical in the industry before, when you want to talk about some equipment, let me share a whiteboard for us to see what I want to actually demonstrate. Now, there are things that we call push button. We call them push button. You'll see them, okay? Sometimes you see green, red, you see a big one, which is an emergency, okay? And then let's say the machine that you are operating is here. So this is what happens on the field. This is the switch, this is the machine. And then you are the personnel that want to perform maintenance on this machine. The requirement is that you must have gone to electrical department, okay? Electrical department. Now, what will they do in this electrical department? You go and obtain what we call line clearance. Line clearance is that you are telling what electrical department, I want to work on this so machine. Please, I need you to disconnect this machine for me for the period of time that I will be working on it. That is the normal practice. You see where this knowledge is very important for even those people that do not have electrical background. Because you must not work, you should try as much as possible not to work on an energized equipment. But in most cases, especially in our industries, especially in this part of the world, there will be some proposals which would actually want to force you that you can manage now. Don't you have flyer? Don't you wear your glove? All these are not enough for you to say you want to go and work on an energized equipment, which you're supposed to take line clearance for. Or you know that at the control room, because there's always what we call control room, especially if you are working in an automated plant, just like a Dangote cement plant. The plant is fully automated. So the control room always starts the equipment. Every equipment, they can start it remotely. That is, without leaving the room where they are, they can start it due to programming. They can start it on the system and say, this particular machine should actually start. And it will start wherever it is on the field. They are only just to press start button on their own computer. So in the control room here, they can remote start this particular machine. So my friend and his Indian boss, they were working on a machine like this. And if I could recall, the machine was 660 volts. I'm still going to explore that. For those that may not know what we are talking about, when you're talking about 660 volts, that's even more than a 3-phase connection. Okay? At least in 3-phase, you should have like 415, or maximally, let's say if you have a very good supply, let's say 440, but 415 is usually what the actual practice. Sometimes you can have less than that, but if you measure 415. So now imagine somebody working on the one that has to do 660 volts. So he told the Indian man, because they are working on an electric motor, they want to actually perform the maintenance. And they have to open the terminal. Opening the terminal means that you are going to be using plier, you are going to be using spanner directly on the conducting part of that machine, electric motor. So he told the Indian man that, please let us go and take clearance. But the problem was that the Indian man supposed to have carried out maintenance on that machine based on the company record, but he missed the particular day. So legally, he cannot go back to electrical now and say he wants to take line clearance. They will ask him, This machine is supposed to have been maintained last week. Why didn't you do it? It's going to become a case on him. And because of that, he wanted to play a smart one, and he himself knew the danger in it. So he was not doing the job. He was just standing and using mouth to control this, my friend, that you should do this, touch here, touch there. And then I was saying that, so where is the line clearance? He said, no. If you have worked with them before, no, you line clearance, no need now, you do fast. We live here. My friend also told him, okay, there is a provision for emergency switch. This emergency switch on the plant, when you press it down, the control room, they will not be able to start that machine. What they will be seeing on their system is error. Until you come back to this place, okay, to go and release this emergency switch. So he told him, okay, let us put emergency switch. The Indian man also knows that there will be question on who put the emergency switch, because the control room, they are going to say that they had a delay of 5 minutes to start that particular machine, and that's going to be an issue, and somebody must answer that question. So he also denied him. He said, no, you cannot put emergency switch. You should just quickly work on the electric motor. Behold, luckily for him, he had already finished the maintenance. He was just covering the terminal of the electric motor, and that is how the machine started like that. He told me of his experience that he nearly even slapped his boss. Just imagine if it was when he was using spanner on that particular conductor. The story wouldn't have been the same like I'm talking about today. It would have been a sad story. But luckily for him, he escaped it. That can be you, that can be anybody. But what is his right? He has his right that he could have maintained his stand that I cannot an energized equipment unless we go and take line clearance. I've heard of funny story, and they are not really funny, they are sad story of NEPA officials, okay, who try to work on a live pole, you know, high voltage, where they're supposed to call office and say, oh, please take down this particular line, we want to work on it. But because they have also missed the maintenance, you just see that it will be somebody they will use as a lab rat. They say, oh, you are the junior staff here, yeah, go. And you also, you want to maybe you have learned, you have been trained, they will tell you that don't you know anything, they will check you like that. I want to show that you know your job. You also want to prove some points. And stupidly, foolishly, the person moved down there. I had a story of a man whose wife just gave birth, was a NEPA official. This person is known to me, is known to our moderator, Mr. Kenny. So I think I had that story from even Mr. Kenny on the day that we actually were discussing about, you know, safety and all that. We're just chatting about it. So he told me of his about this friend of his. He said he was a colleague to him, okay, and then he was a school colleague. Very promising guy, okay. The wife just put to bed, you know, very small baby. So he was a NEPA official, and then they chimed in that, man, come on, climb this thing. When I was like you, I used to do this, I used to do that, and he climbed, and that was it. The connection was taken off at their office, not knowing that somebody was working on the line, and he died instantly. That is an instant death, and that's why electrical is actually very, very electrical accident is very dangerous. You know, it does not give you second chance in most cases. Now, what happens when you have use of tools or equipment too close to energized parts? Okay, look at these connections. You know, we're just using this as an example. Look at this overloading. Okay, so that's what we mean by overloading circuits. How many of us actually still do some connection like this? This can result to, if you go to bed with this, anything can actually go wrong. And also in plant, also there are junctions that are actually usually being overloaded. Now let me show you some images of line clearance. Okay, you see people working on. Now what they are doing here, okay, if you are work on all these kind of breaker in the company before, so they will bring you to this breaker. Okay, they are probably tracing the reading or tracing the supply. They have to bring this down, because most industries, you know, I don't know where you work, you see these kind of breakers. All of them have a machine on the field that they actually supply. So if you are actually working on a particular machine and you are to take one line clearance, you as a mechanical man or whatever may be your department, you have to follow the electrical man to this what breaker here. In your presence, you must take it down, and in your presence, you must actually what put the word light. I'm going to talk about that when I'm talking about what LOTO. So let's move on, because we do have a lot. Okay. Now let's look at electrical safety model. What is the model for electrical safety? The model that you need to actually what follow. We're talking about what the pattern that you must actually what follow for electrical what safety. Now, what is the pattern? The first thing is that you must learn to recognize hazards. It becomes a problem when you don't know that something is wrong. As an employee, either you are an electrical worker or you are a mechanical worker, or irrespective of your work department, even if you are working in bank, when you see what is wrong, you should know what is wrong. What is the definition of an hazard? An hazard is anything that poses what a level of what risk, okay, to either life, property, or environment. That is an hazard. An hazard is anything that poses a level of risk, okay? Anything that poses a level of risk, okay? That poses threat either to life, okay, to environment, or even to the equipment itself, okay? So anything that has potential to cause harm is an hazard in the industry. So now, talking about the electrical hazard now, anything that has the potential to cause electrical accidents, anything whatsoever that has a high what, that has a potential to cause electrical accidents, that is what an electrical hazard. You need to learn how to recognize them. That's why we say that to avoid injury or death, you must first understand and recognize hazards when you see one. Now, when you begin to see, some of these images, okay, that I have been showing you, look at this. When you see something like this, you should know that what? This is what? An electrical hazard. For crying out loud, how can somebody connect cables like this and leave them? No tape, no insulation tape, no covering, and they are exposed. That is hazardous. So when you see this as an employee, either you are working in the electrical department or not, it makes sense, okay? It makes a whole lot of sense for you to be able to see this and say, oh, this is wrong. This is against safety. You need to actually what? Recognize it. Look at this connection here. What do you think that is the problem? Okay? There are many people that when the plug is bad, they remove the plug and they start connecting the cable directly into the socket. That is against the ethics of electrical safety. That is an hazard. When you see something that is wrong, when you see danger, ability for you to recognize that danger is what we call recognition of hazards. So electrical safety starts with you becoming aware of what is wrong. Okay? You need to see it and you need to identify it. Look at this. This plug is burnt. Okay? When you see what is wrong, you need to what? Recognize it. When you see bent poles, some electric poles that are already what? Bending, towards the ground, you know that what? Oh, this is wrong. This needs to be what? Corrected. Okay? When you see somebody walking like this, okay? Let's see if she's using what? Electrical shield. Okay? When you see somebody that is working on electrical, equipment, and perhaps is going to be twisting some conductors together and is not putting on his glove, it is very, very wrong. So look at this man here. That's a very good practice. Let me zoom it for you to actually see the image. Okay. It's a very good practice. Okay, you can see is what it's an electrical goggle that's protecting his eyes against what hacking. He's putting on his helmet. That helmet might not be due to what mechanical impact. There are sometimes that what people's head get what in connection with live cable when they are working, when they forget themselves. Especially if it's a particular joint box where you need to bend, be at a particular elevation or angle of depression to the what, to the equipment that you are working on. You need to protect your head, okay, because you can easily what forget yourself. So you need to recognize hazards. The next thing that you need to do is for you as an employee to evaluate the risk. Oh, this thing is dangerous. How dangerous is it? That is the evaluation of the risk. Oh, this thing that I'm doing is risky. Let me now evaluate how risky is what I'm doing. What would happen if I get entangled with this electrical conductor? What will happen to me? Will it just be a shock that I will receive? Will it be a total electrocution? Will I actually suffer burns? All these things are what evaluations that you need to do. Then, now that we now know the hazards and we have evaluated what the risk, okay, then the next thing is for us to control the hazards. And there are so many things for us to do to control what the hazards. There are policies that administration control, okay. There are cases of what producing what guard on the machines, such that what the part of the machines that can actually open the worker to electric what shock or electric fault or electric accident can actually be protected and covered. And then there are what we call what PPE. So we look at that in this subsequent slides. So let's look at the hazards. Recognizing the hazards. What are the most frequent electrical hazards or injury across industries? So let's look at this. Contact with power lines. That's when you touch the power cable that is actually supplying the particular equipment. I hope you are with me. Anyone in the house? You are with me? All right.
I'm with you, sir. But nothing is displaying.
Oh, you are not seeing?
I'm not seeing the screen, sir. Nothing is displaying.
Oh.
You scroll it up or down. Yeah.
Is there anybody here that's actually see my screen? Who is seeing my screen here?
I see.
I'm seeing your screen.
Now, when you scroll it, you see it.
Okay. Can you see my screen?
Yeah,
Yes.
All right. Thank you so much. So, we are looking at the frequent causes of electrical injury or death. The first one here is contact with power lines. I've mentioned that. I said when you are touching, or when you come in contact with the power cable. That's the cable that is actually supplying a particular equipment. Lack of ground fault protection. There are some times that, what we call earthing. I have an equipment like this. Okay, let me show us in the whiteboard. You can have an equipment. Okay, this is our machine. Because the ground, that's the earth, is a good conductor of electricity. There are sometimes that the body is actually connected with a cable, with a conductor, okay, buried in the ground. That's what we call earthing. So what happens when there is fault in this? When this actually fails, because it can fail. That's what we are talking about. What happens when it fails? That's what we are talking about. Ground fault protection, okay? Another thing is parts towards ground missing or discontinuous, equipment not used in manner prescribed. Now, there are some times that, especially in some industries, it's so common. Every manufacturer of equipment will tell you how to use it. And you will agree with me that most of us in this part of the world, we have some maintenance culture. Most of the faults that occur on machines are due to what? Poor maintenance culture. Because we are not properly what? Maintaining those machines. So when the equipment is not properly what? Maintained according to the what? To the prescriptions that the manufacturer has given, then there's going to be what? A lot of hazards. So you can actually recognize that as an hazard. Improper use of extension and flexible cords, that is the connections across what the plant, when they are not properly, when you don't use them for what it's actually meant for. Take for instance, you can't how many of us connect, how many of us plug? Please don't lie to me. Okay, I need somebody here to tell us, how do you differentiate a 15 amp socket and a 30 amp socket? Is there anybody here that can try?
Yes.
Okay. Okay. Ali, Ali, go ahead. Ali, please go ahead. Tell us.
And please signify if you want to speak. Signify if you want to speak, please. Okay, Bolaji Adepoju, you can unmute your mic. Bolaji Adepoju.
Okay, sir. Good evening, sir. I think to differentiate 13 amps from 15 amps, number one, all the electrical appliances are power rated. From their indication, we can see that. And from physical appearance, 13 amp socket is usually in the rectangular, I mean the pin mouth. Why the 15 amp socket usually to be in a cylindrical form? That is the two way I can take to differentiate. Number one, by indication, and then number two, by physical appearance. Thank you.
Okay, thank you so much. Now, what I want to ask now is that, how many of us plug our, I'm going from industry, we are cutting across. Okay, I'm just using what anybody here that does not even have electrical background will actually relate to it. That's why I'm coming low to those words illustrations. How many of us plug ions on a 13 amp socket? You risk it, like for a while you use it. Is there anybody here?
Yes.
Okay, you do that. Who is
Yes.
that?
So, Jola,
So why do you do that?
I can't really know it.
At times when you are in a hurry. Okay, now that's what I'm talking about. Okay, so when you load, when you load a particular equipment, that its current rating is more than the source, then there is a problem. Okay, there can be a problem. Okay, and if you are lucky, it might be that you just replace that particular source. And if you are not lucky, it might result to something else, especially if you are not the one handling it. If it's somebody at home, or if it's somebody in the industry or in the department that is actually interacting with that machine, you understand it anytime you want to use it. You're always careful with it because you know that what you have done on it is dangerous. But that person might not be so careful. That's what we are talking about. So that's why this play is talking about improper use. Careful planning of our safety procedures. We need to know that this also helps in reducing the risk of injury. When you plan the safety procedures, when you have a careful planning, towards the safety procedures, then it can actually reduce the risk. And when there is a decision to use LOTO, I'm going to be explaining this LOTO later. When there is a decision that a company say, oh, we are going to be operating LOTO on any equipment that anybody wants to work on, then this also facilitates electrical safety in companies. Electrical hazards. What are the hazards that may result from electrical faults? Explosion. That's the very first one. Explosion due to electrical fault. Because you should know that electricity provides ignition. Okay, when you have a flammable atmosphere, or when you have explosive mixture in the atmosphere, they just need an electrical spark, just a little spark, and then you have everywhere engulfed with what? Fire or exploded. Okay. There can be what? Fire incident. Unlike explosion, you can also have what? Fire incident due to what? Electrical what? Fault. And in fact, if you have undergone fire safety before, because it's part of the curriculum of this what course, fire safety, we're going to talk about it. Fire safety will show you that one of the dangerous type of fire or class of fire to fight is the class of fire that is caused by electrical, fault. Because aside the fact that you are fighting the fire, your life can be in danger. You can also be exposed to what? Electrocution. You can be exposed to what? Electrical hazards, even while fighting a fire that is caused by what? Electrical source. So that's what I'm talking about. So it can be overloading of the circuit that causes that. It can be excessive current flowing through a particular faulty wire. I've seen a situation before where, there was a spark just from a source and the fire started tracing the wire. From that place, the fire started burning, and it's usually very fast. Fire being caused by what? Electrical source is usually very fast. If it will burn the whole cable or burn the whole equipment, it's going to what? Take, in minutes, everything is what? Everything is burned to ashes. Arc, flash. For those who are not electrically inclined, might not know this, but I will show you what arc flash looks like. Okay? I will show you what arc flash. Okay, you see it like a spark. Okay, so we call it arcing in most cases. Okay, look at this. This might be due to what? Arc flash. So what you will see it with, let me give you a very close way for you to notice it. Sometimes when you try to operate your switch, when you press that switch, you see something like a whitish light discharge, like a spark of very whitish light discharge. That is what arcing. Okay, when when the electric current flows through what a different path other than what the path that has been created for it, that is what you have what arcing. You see, electric current leaves its intended path and travel through what air from the conductor to another. Then that is what we call what arcing. So it's just like let me demonstrate that for us to see. If I have a switch, okay, if you have a switch, normally the connection is that if current is coming here, okay, current is entering through here. If I press this switch, the path that this current is supposed to flow through is supposed to flow through this switch. But what happens, okay, when the current jump through the air and don't jump at this place? What happens? That is what arcing. So you can see the way it comes, like an arc. This is the shape of an arc, okay? So that is why we call it what arcing. It will come like an arc. This is where the current is supposed to be. It's supposed to go straight like this. But maybe this line is already what 40, or is actually small to the what amount of current I want to pass. You just see the current will just jump with a flash of light. Okay, just like your lightning, it will jump and it will form an arc like that. That's what we call it what arcing. Okay, it's not a deep electrical course, it's just an inclined. I would have delved deeper than that. Now let's look at the evaluation of risk that we are talking about. You should know that what not all risk is equal. All risks are not what equal. I'm going to show us a particular diagram here. All risks are not equal. Okay, so when you're analyzing the risk, okay, of the electrical fault, you have to analyze it with the probability of an injury occurring. And if this injury should occur, what would be the severity? So in other words, what we are saying is that what risk is calculated by probability multiplied by what? Severity. Okay. Now, what are we talking about? What is the probability that this equipment will result to what? Electrical what? Accidents. So how to calculate the risk? You need to first know the probability. Take for instance, a well-guarded electrical equipment will have a low probability to an electrical equipment that is not what, whose connection is not what, guarded. So if I open all the what connection and the wires are like this, okay, I've just increased the probability of electrical what? Accidents. So there will be probability. Now, sometimes probability might be low, but you now ask yourself again, eventually, if this accident, electrical accident actually was occur, how severe will it be? Severity will not be telling you. Will that be what? Just a shock? Will that be just a shock? Will that be what? Burns? That's the question that severity will be answering. Okay? Will that be, electrocution? Will there be contraction of muscles and the likes? So you begin to answer what? All these questions. That's when you test out what? The severity. How severe will it be? That's what we are talking about. So you identify the hazards that could lead to injury or that could lead to what? Death. That's what we are talking about. You have to identify them. This can only cause injury. This can lead to death. So it will help you to know how to actually what? Safeguard the what? The equipment, or protect what? The employees, or protect yourself against what? Electrical what? Accident or electrical what? Fault. Okay? So look at this diagram. I just hope we can see this. Now, this is the evaluation of risk. This is what you will see in most what? Say, safety analysis when it comes to what? Risk assessment or hazard risk assessment. So you will see this diagram. Now, this column is dealing with what? Probability. You can see where I put the red. You can see probability there. This one is dealing with what? How severe will it be? So, what is the level of the probability? We have low, we have medium, we have high. What is the level of what? Severity? We also have low, we have what? Medium, we have high. So when you take a particular hazard, that particular electrical hazard now, or any hazard whatsoever, anytime you are doing a risk analysis or risk evaluation, you have to get what is the probability. Is it low? Is it medium? Is it high? And what is the severity? If it eventually occurs, how severe will it be? Will it be low? Will it be medium? Will it be high? So that we know, okay, what to do, okay, and how to actually control it. Take for instance now, look at this practice now, this one now. This person wants to replace a 120 volts, want to replace a 121 volt AC equipment, want to replace it, and then when the analysis of the risk was actually done, it shows that the probability of having electrical faults or electrical accidents from this is low. So you can see that it falls on low for probability. It also falls on low that if it eventually occur, how severe will it be? It also falls on low. So when you plot this, you see that it is low probability, low severity. And that's the kind of risk that you can take. You can take this risk because eventually we can see that it's very rare for electrical fault to occur due to this. Electrical accident to occur due to this. And even if it occurs, the severity is low. So then the company can say, okay, fine, this kind of job, perhaps the employee will just wear PPE and then go ahead to do the job. But look at this. The one of repair of 230 AC motor. Okay, what do you see here? You see that the probability fall on. Can we see my screen? Can anyone see what I'm doing?
Yes, we are seeing.
Yes, your screen is not. Yes, yes.
You can see that if you trace from probability, you see that the probability of the electrical fault here, the risk from here is on medium. And then you will see that the severity is also on medium. So you will see different color. The blue color you are seeing here means that what this anyone that fall under low probability, low severity is safe. You can work on it. Now the column was changed when it comes to what probability being medium, the severity is also medium. Because here now we know that what something may actually go wrong. It has already fallen on the medium. So here we have to take in, even though we are going to go ahead with this kind of job, there must be a lot of things being put in place. The line clearance, the PPE, the procedures, everything must be what put in place to safeguard what the life of the people that will work on this equipment. But look at the story. The story will change when you come to what installation of 7.5 kVA transformer. Now we now did what the risk evaluation. The risk is high. Can you see that? It's coming from high. And if eventually what electrical fault will happen here, what is the severity? The severity is high. This kind of job, don't try it. That's what we are saying. So you can see how risk evaluation will expose the kind of job that is dangerous. So it means that if we are going to work on this, we have to de-energize it. We can't work on this 7.5. We can't be doing the installation when the supply is actually on. That's what we are talking about. Evaluating the risk here shows that what the risk is actually what high. You can't be working on a live cable that is going to be feeding 7.5 kVA transformer. The probability of electrical accident is high doing it. And if it eventually was occur, probably it will lose towards death, not even injury, death. That's why what the severity is also high. So that is how. So you can always plot that particular word. That you can always make that practical, and that's what I'm going to actually demonstrate now. Is there anybody that wants to volunteer? I need somebody to volunteer. You will give me. Let me tell you what you are going to give me. Give me a particular industrial related electrical work. Okay, you can give me like 1 or 2, and then we are not going to try to plot it. Can it be done when the supply cable is energized? Is there anybody?
All of Insola, I can see your hand. You can unmute yourself. All of Insola, are you there? Okay. Good evening, I'm here.
Just
the one I want to talk is when we have 7.5 kV compressor. Oh, okay.
Okay. 7.5.
The rating 3.5 kilowatts electric compressor.
3.5 kilowatts compressor. Okay. So, do you have any other one? Do you have any other one?
And 10 kilowatts.
Okay, 10 kilowatts.
Yes.
Now, let's look at this as you want to perform maintenance. Which of them you want to perform maintenance? So we are looking at them being what live table. So let me zoom this now. Where does it come? If there is supply, if the supply is on, where will your 3.5 kilowatt compressor fall on? Under probability. What's the probability of electric accident on it when it is energized?
And looking at it, I think it should be
medium or high.
That's medium.
Medium. You have worked on it before. Yes. Medium. What about the severity? If eventually electrical accident now occur on it, will the severity be low? Will it be medium or high? What
It's
can happen?
medium. It's medium.
Why do you say medium? It cannot kill.
Its probability is yes, yes.
It cannot kill.
It's medium. The severity will be medium because of the rating.
Okay, severity will be medium. Okay, but what is the probability?
It can kill 3 phase. 3 phase, it can kill.
That's what we are talking about. So what is the severity? The severity is high.
The severity
If it can kill, the severity should be high.
The severity should be high. I'm just being practical with you now. You need to analyze the job that you are doing and know I'm actually showing you how to do your own risk evaluation. This is a practical class. You need to be able to evaluate so you can see now others are contributing because it can kill. It's 3 phase. What we are talking about is what? 415. Especially if you now have it complete. If it's not the one that drops to 380 like some that you are going to use your meter is going to show 380 or so. If your 415 is complete, just imagine 415 flowing through you. Because I know for you to perform the maintenance, you have to what? Use your spanner, is that also? On the terminals and all that. So the severity is high. But what is the probability? What is the probability? The probability is medium. So that means that what is going to be here. So look at it. So if you bring it here, your 3.5 kilowatts will be here. So if you trace it, probability will show that what? It is from medium. Can we see this? Probability is from medium. Can we see this?
Yes, right. Yes, right. I can see it.
Severity is high. So you look at what is follow. So you can always plot like that. I'm just showing you now that what it doesn't have to be medium. It doesn't have to be high. One can be medium, the other one can be what? High. One can be low, the other one can be what? Medium. Either probability or severity. Now, when will you put your 10 kilowatts? What is the probability? Anybody can help. What will be the probability on 10 kilowatts?
Charles, are you there? I've been hearing your voice since. Yes, sir. I'm here, sir. Okay, please contribute.
So
the probability will be high. The probability will be high.
It will be high.
Also, the severity will also be high.
Okay, so your 10 kilowatts
because it demands higher voltage.
Okay, that's it. Yes. So this kind of equipment, you need to de-energize it.
Yes.
You need to de-energize it. You can't work on a live cable like this. Okay. How many of us work on our electric socket at home, even without switching off? Is there anybody that has done connection on or something?
Yes.
Normally.
Okay. Now look at that now. Look at that now. You can plot that here, working on sockets. Your socket at home now. So what will you give that? What is the probability? Why are you trying that? You know, it's not de-energized. You did not de-energize. You did not switch it off, even though it's still a wrong practice. But now you are actually we are doing the evaluation of the risk on it. What will be the probability of you receiving shock from your?
It will be low.
Medium.
It will be low.
Oh, okay, I agree with that. Now, eventually, let's say you now receive electrical, accident. There's an electrical accident on it. What can it do to you? How severe will it be? Will it be low, medium, or high?
Medium.
It can be medium.
It will be low or medium. Depending on the resistance of your body.
Okay.
Yes.
You got me laughing. The resistance of your body.
Okay, please let's be organized. We want to speak, just indicate, signify rather. I will call you.
You will tell us how to calculate the resistance of the body. But look at that. Your socket, your 30-amp socket, okay, actually fall on this place. So somebody is actually doing that. I'm not encouraging that. But we are just looking at it based on what the risk was evaluation. Okay? Somebody working on this might just say, oh, let me quickly connect it. And You know, you might actually say you are doing that, but you can't try that with all these 7.5 kVA transformer and all that. That's what we are saying, because the probability is high, the severity is also high. Now let's look at types of electrical accidents. These are the types of electrical accidents. Shock. Okay. Anyone here? Go to the comment section if you have received electrical shock before. Okay, I know it should be almost all of us. Electrical shock, just type yes. Let's make this lively. Electrical shock, anybody? Go to the comment section. Can you see my screen? Yes, electrical shock. Of course, we have regular customer here. Shock. Everybody is saying yes. Okay, let me step it up. So let's look at the second one. Burns, electrical burns. You have added burns due to electrical, fault before. Maybe you touch a very hot metal. Okay, let me analyze them first before I ask you. Let me take them one by one. Okay. Let me take them one by one. Okay. So if you have had burns before due to electrical, type yes. Can you type yes? Let me see that. Anybody that has been burnt, you felt the burnt, or maybe there is an electrical burnt, maybe hot. Yes. I have some yeses here. Okay. No burns. Okay. Anybody who has witnessed fire incident due to electrical spark or fault before? Anybody here? Electrical, yes. Fire being energized by electrical. Oh, a lot of yeses here. I won't say that as great. It's not something to be encouraged. Explosions due to electrical spark. Explosions. Type no if you have not witnessed it before. Explosions. Joseph, are you saying something else? Joseph, can you unmute, please? Mr. Moderator, please let me call Joseph out.
Yeah, I'm here.
Okay. Did you say yes to explosion?
Yes, I actually witnessed one.
Tell us how it happened.
I don't know what really happened or what really caused it, but it was a very loud bang. So scary, and there was fire everywhere as if it was fireworks on top of the electric pole.
Wow.
And it was really bad. It wasn't a sight to behold, honestly.
Wow. Thank God it didn't happen to you. You saw it happening to someone else.
Yeah, so God.
It
It was really scary, honestly.
Thank you for sharing. Okay. Arc flash. How many of us guys have felt arc flash before? I need to bring up something on that arc flash. I think I have something on arc flash. Something is also very scary. You must have, if you have worked on a two very loaded connection before. So you can see arc flash incident. Can you see on my screen what I'm displaying? Look at this. Look at that. This is a result of the arc flash. Okay. Okay. You just see it just come like an explosion. That one will also come like a flash, like a flash of light. It does happen sometimes. If you have done it before, if you use the red cable live wire to touch what the neutral wire, you must have seen what I'm talking about. What maybe mistakenly they touch each other in your presence. Then you see hey, you can see
I have witnessed all of them.
You have witnessed all of them before. That's not fantastic. So now the last but not the least, let's mute, please. Mute, please. The last but not the least is what? Falls resulting from electrical injury or incident. And this happens a lot when you are doing what? Electrical work that has to do with what? Work at height. Falls, when somebody fall off due to electrical work, fault is a scary sight. It's not something to witness at all. Now I want to just show us for you to see the effect of electricity due to the measurement of the what ampere rating of them. You can have a tingling sensation, just a tingling sensation. I know many of us must have felt that before. It will be as if the electrical, the current is massaging your finger. The feeling may not travel beyond your finger. So if the current rating is between 0.7 to 1 microampere, okay, if you have milliampere of 0.7 to 1, what you will just feel is tingling, just tingling sensation. Okay, slight shock. You can have a slight shock, but not a painful one. Okay, you may not lose your muscle control with it if you have experience. If you are exposed to 1.2 to 1.8 milliampere of what current. Okay, shock, a painful shock this time around. Okay, but yet your muscle is still what? Secured. That's when the current is up to 6 to 9 milliampere. Okay, shock now, not just painful, but a severe one. You feel that there will be muscle control loss, there will be breathing difficulty. Okay, there will be onset of let go threshold for you also. Like that's when you get exposed to 15 to 23 milliampere. So you can see this. Possible ventricular fibrillation. Okay, that's when you are exposed to about 0.1 ampere, okay, of current. So you can use this to know when you are working on equipment, like the first person that answered the question when I was asking about how do you differentiate the 13 amps and the brilliant answer is that what all equipment, when you take your time to check them, you see the current rating on them. And with the knowledge of this class, you can see what you are open to. If this should actually come in contact with you or you are exposed to it, what should you expect? That's what we are talking about. So you should know the one that can give you what? Just a tingling sensation, the one that will give you slight shock, the one that will give you what? A very big shock, not painful, severe shock, possible ventricular fibrillation, possible heart muscle activity ceases. Okay, seizure of what? Heart. You should also know about that. That's the one of 0.5 watt ampere rating. Okay, and tissue and organ burn is one of 1.5 watt ampere. So when you look at what the current rating, you should know what the extent of danger that could actually what occur to you. So I have them being itemized here, so you can see what is the what effect on person. 0.5 to what 3 milliampere, tingling sensations, 3 to 10 muscle contractions and pain, 10 to 40 milliampere. Let's go threshold. If you have felt down before, that's you wanted to actually what to drop the cable, but it will just be as if you are magnetized. For those who are deep into electrical, you'll be talking about electromagnetism and all that. Like an induction. You told the conductor to an induction to magnets, to a temporary magnet, and then for you to let go would be very, very serious. So I think I've actually experienced that before. I've experienced that before. And when you come out of that, it's just it's just the grace. Though my own was actually domestic, I've always been very careful when it comes to industrial safety. I've always been very careful. And the one that I even experienced domestically was very, very many years ago. Even before I got to have a deep knowledge of electrical, I was still very, very little. So I'm talking of many years ago, but I still have one. The memory is still fresh because it was a very terrible experience. But I've always been taking my word, electrical safety. I don't take it with a joke. And that's what we are actually doing with this training. So the burns can be thermal contacts. So when you have your skin, touching the overheated electric conductors, this can be from your hot plates, or if you have any hot, electrically powered hot metal or hot equipment in your place of work. For example, in my own place of work, even though it is not electrically fired, but there is a lot of electrical equipment that is working with it. We have cane. That's a cement plant. We have cane, rotary cane. We call it rotary cane. Okay, and when it is fired, you're having about 1,000. It is fired up to about 1,450 degrees Celsius. To the extent that when you are passing under it, you are passing, the rotary cane is always very high up. When you are walking beneath, you will feel, even some meters away from it, you will feel the radiation of the heat. Okay, so these are thermal burns. If you suffer burns due to this, if they want to maintain the cane, they shut it down for like 4 days. It's still cooling down. Nobody can go near it. Okay, so electrical burns also, we have electrical current flows through our tissues. When electrical current flows through your tissues, there will be burns. There will be burns, and skin deep or affect deeper layers of your muscle. That's electrical burns. We have arc burn. I just showed you arc burn here. Okay, in this diagram, you can see arc burn. This is burns. Look at this palm. The person was actually, so you just hear this one is just like the way you see those people that do welding work. Okay, when you see that light that is coming out of them, so the arcing light is like that, and then it just comes like that, and then you have the burns. Look at this person's armpit here, the arm and everything. That's a serious burn there due to what arcing. And you must note that the three of them can happen together. You can be exposed to the burns due to thermal contact, due to electrical, and due to hacking. The three of them can actually happen all together. So hazards. Let's look at the controlling hazards. So we should know that you can control hazards, and you may also, let's say that you can minimize the risk. Okay. Number one, by creating a safe work environment. It is very important. If the work environment is safe, you will be able to overcome a lot of hazards. Okay? If all the connections are properly done, you can overcome electrical hazards, a lot of them. If the floor is not wet, you can overcome a lot of electrical hazards. If the equipment all the electrically energized equipment are properly covered. Okay, when you have their cable being joined together, just like you having your junction box at home without being covered. So there are situations that when you get to plants, for people like me who are in the field of safety, that go into company and help them to look for loopholes of their safety culture. So we check it for them, and then we tell them, we recommend, you need to improve on this, you need to improve on that, you need to do this, you need to do that. For some of us that do that, you will see that your awareness of electrical faults or things that are not right, your awareness will be very, very high. So when we walk around like that, we can easily spot things that are not being done right. Oh, this is not good for your work environment. Can you change this? Can you replace that? That socket is no. Most of the welding sockets in some industries are not properly installed. Okay, most of the equipment are not properly plugged in. If they are not properly plugged in, this can increase, it can generate what? More heat than necessary. Okay? If some cables that used to connect some equipment, due to their current rating, if the cable cannot support them, you should be able to know that there will be overheating through the cable. And in a very severe condition, this might actually generate the cable can get burnt along the line. So the work environment is a sensitive place that you need to first put everything right first. So if the environment is safe, you can guarantee that 75 or 80% of the electrical accidents that may occur can actually be mitigated or minimized or controlled. Using safe work practices. What about the practices of work? If the regulation says for every electrical worker you must use your hand glove, then you should know that using your hand glove becomes very, very paramount. You must not be seen. It's just like the health workers. Before you can attend to any patient, you must put on your surgical glove. That surgical glove is to protect yourself from germs. You also, as an electrical man, you must use your glove. If that is the regulation of your company, do not say that this one cannot touch me. I'm very confident. How many years I've been doing it, nothing can happen. I will touch it. I've even heard of people, who can actually place bets on the fact that they can. I don't know how they got their own experiment, or maybe they find it in a physics textbook or anywhere, that when you seize your breath, electric shock you can't feel electric shock. That's a very dangerous idea. Unproven hypothesis for anybody who wants to uphold electrical safety. For you to say that you are going to touch a light cable, you seize your breath and nothing will happen. That is wrong. It is not a correct practice. So the practices must be right. If we say that people must take line clearance before they can go and work on equipment, like the story of that my friend I shared with you, you must adhere with that rule. Violation to that rule should attract punishment from the company, management. In the industrial management should frown at anybody, even though you have done the work, you escape the risk, nothing happened. That doesn't mean that if you continue like that, it won't happen one day. So if you must wear your glove, wear your glove. If they say this place, helmet is needed, wear your helmet. So that is what we talked about. The best method is for you to keep a safe work environment, for you to actually uphold the safe work practices and being properly trained. That's another problem. In most cases, we assume, I already mentioned that from the beginning of the training, that induction in every company is necessary. How many of us went through induction in the company where we work? If you went through induction in the place where you work, can you please go to the in-messages and type yes? Was there an induction for you, like with proper orientation? I've seen only one person, Charles. Is there another person? 2, Popola, Joseph, 3, 4, Adex. Okay, great. There should be, I don't want to know where you work. So that, so many people will not start writing applications to your company, and then you want to take your job. So proper orientation is very important. People need to be trained. People need to be trained, irrespective of the experience they are coming from. Even you that you are raising your hands, if you should leave your company today and go to another company, it is very, very, required that you should also still be trained based on the environment where you are presently working. So, limit exposure. We are talking about you should reduce the amount of time spent around high energized equipment. It's very important. So you should limit your exposure. The time interaction should be very, very what? Low, should be small. Maintain distance. When you have a highly energized what? Equipment, you maintain distance. You need to know that when you have transformers being installed all around in your company, you shouldn't walk too close. Any of us in the theoretical aspect, I don't want to go into it. There are eddy currents, you know, there are flux linkages that can actually happen around your transformer. So you don't need to, most of the accident and deaths from transformer that I've heard of, even the person doesn't need to touch it. Okay? In high tension, there is what we call corona effect. Corona effect. Just to tell you that one, all the air that are around the world and electrically what energized conductor, all the air that surrounds it, they are ionized. They are also charged. They are turned to charges. So that's why you will be hearing the sound when you pass through your product very close to your transformer or any high cable that is carrying what high voltage. You'll be hearing all the sound like something like that. That's what we call corona effect. Okay, so you should maintain your distance. Okay, when you are walking, you can also bring what a particular mass in between you and the equipment in case there will be explosion. And if it is required in your company, then you need to wear your PPE properly. You need to learn how to wear your PPE properly. In fact, I encourage people, even if your company did not give you, you can actually get some for yourself, so that you can keep yourself safe. It is very important. Now, let me quickly talk about this before I allow questions and all that. What are the protections against electrical hazards? The first one is the insulations. You can use insulations. I've talked about that. Insulations are poor conductor of electricity. So if we coat or we cover a good conductor with a material that can easily conduct electricity, so that material that cannot easily conduct electricity is called insulation. So one of the ways you can actually achieve safety is for you to, cover a good conductor with a poor conductor. And that's when you see your plier. You can use your plier, to twist light cable together, because the angle of your plier, okay, the place where you put the effort of your plier, it is actually insulated. Okay, and it is not even ideal that you use it to twist light cables. I'm only saying that it's actually the insulation was placed on your plier, so that in case you don't even know that there are supply there. It's not meant that you should really be using it to twist light cables. I've said it time without number that you should try to work on a dead circuit. Do your best. If you can actually shut it down, let it be that you're working on a dead circuit and not energized circuit. There can be guarding. Guarding means that you can provide a guard around the equipment, so that your hand cannot touch the cables, your hand cannot touch the light cable or the exposed part of it. You can put a guard around it. Grounding, you can connect the body of the equipment to the earth. In case there is leakage current, then it flow to the earth. The grounding is like creating a part of low resistance, to the flow of current. And you know that current will always be attracted towards a place where there is low resistance to it, just like human being also. You would like to go to a place where they are not pushing you back. So if you have a part of low resistance for the electric current, you can save the other body, which is you in this case. So we can connect to the ground, because ground is a very good conductor of electricity, and it has a very low resistance to the flow of electric current. And we have electrical protective devices. Those are your what? Your devices that can help to safeguard, in case there is maybe an overload, okay, or a short circuit. We're talking about your fuses, the fuse can blow out. Therefore, discontinue the flow of electric current, and then there is what? Safety. We have circuit breakers. Many of us have these. You are interacting with it in your industry, or even in your what? In your household. We have what? We have a grand fault circuit interrupters. We call it GFCIs. So what happens when there is what? In the grounding fault, earthing fault. So these interrupters are the ones that will actually help, okay, to still save what? The equipment, or to save you from what? Being what? Electrocuted, or being exposed to what? Electrical what? Accident or fault. So let's take it here. We have a whole lot. Tomorrow we will pick it up from where we stop. I'm going to be diving into the electrical safety, talking about what the PPEs that are needed for you and how you should properly wear them. We are going to be talking about what LOTO itself, not that tag out. I've mentioned some part of it today, but what are the necessary steps and procedures that are needed for you? And tomorrow I'm going to be dealing with what? Fire safety. Also, what are the required what skills? Okay, the required what techniques from you in case there is what fire incident resulting from what electrical, source or electrical fault. How do you fight this? And so many other things that we need to actually what cover. So everything will be covered tomorrow, talking about what energized electrical work permits and all that. So we'll be discussing all this tomorrow. So I hand you over to the moderator. So if there are any questions for me, thank you.
Okay. I want to appreciate our resource person, Mr. James Fanny, for that engaging session so far. It has been a very, very engaging one. Okay, let me bring down my screen. So okay, thank you very much. Okay, so quickly, it's 8 minutes to the hour of 12. So let's take questions. Let's see what we can do. Questions within the next 5 minutes. So please, if you have your question, just signify by raising up your hand. So I'll call on you. Thank you very much, Okoyemi Latif Robinson. Yes, Robinson, the class is being recorded, and yes, we are streaming live, so you can, check the recorded class on our YouTube live page. Okay, so quickly, let's take questions. If you have questions, just signify by raising up your hand. Okay, Mohammed Dahiru, just a minute. So you'll be able to. Mohammed Dahiru, you can unmute your mic. You can unmute your mic and ask your question. Mohammed Dahiru. Mohammed Dahiru, I can see your hands. Okay, so please, if you have your question, let me lower the hands first. So please, if you have questions, and those who are with us on the YouTube live, if you have your questions as well, you can drop it in the comment section. We'll do well to respond to them. Questions. You have field experiences you want to share with us. Let's do that within the next minutes. So just signify by raising up your hands. I'll call on you so you can ask your questions. Okay, so I want to assume the class is quite understandable. Let me check our YouTube page to see if we have anyone with questions from there. Okay. Okay, so John Paul, you can unmute your mic. John Paul, you can unmute your mic. . John Paul, I can see your hands. John Paul Ihediri. You can unmute your mic and ask your question. Okay, and if you can't, okay, you dropped a question in the comment section. Okay, let me see that. Okay, so if you can't speak now, perhaps you are in a busy environment, you can drop your question in the comment section. You can drop your question in the comment section, so we'll respond to it from there as well. I'm trying to bring up John Paul's question. Mohammed, I can see your hand as well. You have
Yes,
a
good
question.
morning, sir.
Okay, please go ahead.
Yes, my name is Mohammed. I really want to appreciate the organizers of this seminar. It has been a wonderful one, sir. We are grateful, sir. And from the discussion so far, sir, there's an important aspect of safety that I wouldn't know, maybe it is part of the subsequent lecture, but you've not talked about it, which is toolbox talk. I think is very, very important in safety. Without it, safety is zero. Even if you've been able to take all the precautions and what have you, if you did not do the toolbox talk for every job that you want to do. So I would like you to keep in that toolbox talk in your next discussion, sir. Thank you.
Okay, thank you very much for that observation. Toolbox talk, of course, yes, is part of what we are going to be discussing. And in the next class, that is tomorrow's class, I think the resource person, our trainer, is going to be talking on that aspect. Okay, so let's wait till tomorrow's class, and in our subsequent follow up, maybe during question and answer, we can also chip in more about that. Okay, so thank you very much. John Paul,
moderator, please tell him to put that in the in message so that it can be documented and factored in.
Okay, so Mr. Emmanuel,
just ask the question now.
Yes, the resource person is asking that you drop it in the in-message section. Just put it in writing.
Mohammed, not Emmanuel.
Muhammad Yahaya. So, pardon me for that. Muhammad Yahaya.
Okay, sir.
Oh, okay, so please help drop it in the in-message section. Okay, so John Paul was asking difference between the 12 amp and 12 amp. Perhaps you mean the 15 amps and 19 amp socket. I think the contributor actually mentioned some things. Okay, so if there's any additional things to that the resource person wants to say, then you will hear from him. Okay, so there are no questions again. Okay, so Mr. James, over to you. Do you have any contribution or passing thoughts that you have for us based on the questions and comments that have been made so far? Mr. James, over to you, sir.
Okay, thank you, Mr. Kende. Am I audible?
Yes, you are. Please go ahead.
All right, thank you so much. I think the only thing that we have as the question is just the question about the difference between 13 amps and 15 amps. So maybe the questionnaire didn't actually get the question very well. So there is nothing like 12 amps. So we are not talking about 12 amps. We are talking about 13 amps and 15 amps. Okay. And let me see if I can just share my screen to. Let me share my screen so that I can just show you. So it's just the current rating on it. Okay. It's the current rating on the socket. So you can see this. So the one that you are seeing here, that is just like a rectangular shape here, that is the 13 amps. So on your 13 amps, you can plug your phone, you can plug your extension, you know, your TV set can be plugged on this, your fan can be plugged on 13 amps, because the rating of all these gadgets that I'm mentioning, okay, their rating, their current rating is, you know, either below that rating of 13 or just thereabouts. But for 15 amps socket is for you to, especially when you have heating elements like your boiler ring, like your cooker, okay, your hot plate, your iron, because you will see that most of this equipment, they pull a great deal of current. That's why their cables are usually thick, is usually what robust, because they are depending on current for their functionality. So you see the one with round shape here. Okay, this one with round shape, that's how you see, you differentiate the 15 amps, and the one with either square or this rectangular shape is your 13 amps. So physically, I've just shown you the difference, and that's all. Thank you so much for attending today's training, for being attentive. Something I always say is that you still need to go back to the recording of this class. It's going to be dropped, so you need to watch it again before the next class, so that you can solidify the knowledge we have passed across here. And try to subscribe to the YouTube channel. I think I've had a moderator saying that. So rewatch and watch, so that tomorrow, when we are building on this, you will have solidified your knowledge. So thank you so much for your time.
Thank you very much, resource person, Mr. James Fanny. Thank you very much for the wonderful session so far. Okay, so are these questions I can see Opayemi Latif?
Yes.
Okay, so
Thanks so much for the program. Really appreciate. My question is, I want to ask if the material, the soft copy of the material can be shared for us.
Okay, thank you very much. Okay, so it's our practice at the end of every of our trainings, we share training material, the resources we use. So you are going to get it. The only condition will be those who are putting in for the certification for the course. Definitely the materials will be sent alongside their certificate for the training. So definitely the material is going to be released at the end of the training. So thank you very much for your question. Okay, so we are going to be dismissing from the class, but before we go, let me call on one person to give us the feedback of today's class. So please, your feedbacks are very important to us. At the end of the training, please just go on the WhatsApp page and drop your feedback of today's class. We want to hear your view, we want to hear your comments, and these are the things that we need and do in order to help us improve on our subsequent classes. So please, your feedbacks are very, very important to us. Drop it on the WhatsApp page or even on our live YouTube page. You can comment and drop your feedbacks there. So please, our YouTube platform is there for you to have ample access to our trainings and to get updates on the several trainings that we have. Do well to subscribe to our YouTube page. It's important that you'll be able to get notifications for maybe the new classes or trainings that we have that we are giving out for free. So please, ensure you subscribe immediately you leave this class. The YouTube link that we drop for the training class, the live class, you can through that link access our YouTube page and just click on the subscribe button. So once again, I say a very big thank you to everyone. Janet Kulori, if you can hear me, we'll also have your feedback on behalf of the whole class. Janet Kulori, if you can hear me, you kindly unmute. We want to get your feedback. How was the class and what do you have to say to us? Okay. Choice Okeke. Choice Okeke, if you can hear me, you can unmute your mic. Choice Okeke.
Yes, sir. Can hear you.
Okay, thank you very much.
Hear me?
Okay. Yeah, I can hear you. Please go ahead. We can hear you.
Okay, just a quick one, please. I'm not on the WhatsApp platform and also the YouTube. So I don't know whether it's possible to drop the link so I can also join through there, or maybe is it sent to the email that was sent to us? So I just wanted to know.
The WhatsApp platform.
And for the class, it's good.
Hold on, let me see if I can drop the link immediately. Okay. Sorry. Okay, so I will try to drop the link. I'm trying to get the WhatsApp group link. Okay, so on that note, I want to appreciate everyone who has been a part of this class, this training so far. Thank you very much. Tomorrow is another day. We are going to be here same time. You don't want to miss tomorrow's class because we still have a whole lot we have a whole lot to discuss, to train on in tomorrow's class. So you don't want to miss it. So 10 a.m. tomorrow, we are going to be meeting here. The same classroom link is going to be used. So endeavor to make it to class on time. So thank you very much, everyone. I called on someone to give us a feedback. Okay, on Noja Adama, thank you very much. Thank you so much for the training. Thank you very much for your feedback. Okay, so Mr. Choice, okay, I've dropped the WhatsApp link so you can join that WhatsApp group immediately before we close the class. So those who have joined us on our YouTube page, thank you very much. And then Michael and every other person who has been a part of this class, we appreciate you a whole lot. So till we meet again tomorrow, same time, do have a productive day ahead. So you can unmute your mic and tell me bye-bye.
Bye-bye. Thank you so much. It has been a
Thank you very much.
session.
Bye-bye. Thank you so much.
Bye-bye. Thank you so much.
Bye, well organized and well coordinated.
Thank you, sir.